This is going to show you how to use Google Colabfold to predict protein complex structures. So the first thing you're going to do is you're going to Google Colabfold. And it's this link, this AlphaFold 2 IPYNB Collaboratory. So this is the software you're going to use, but you're not exactly ready to use this until you've collected your sequences. So let's collect our sequences. So we want KSHB or F45, and then you're going to search UniProt. So you're going to look up the protein name and then UniProt. UniProt is like the protein database, and so you're going to get the sequence from it. So you're going to go to sequence, download, copy and paste this. So copy, go to a Word document, and in your Word document you're going to have your name of your first protein and then your second protein. So let's do ERK. So paste the sequence of the first protein, then get rid of any spaces like what I'm doing here. Perfect. And then you're going to put a colon, and this colon separates the two protein sequences of the two separate monomers that you're trying to create a complex with. So you need to get your second protein complex, so ERK, UniProt, except you want it in the right organism. So this is in Candida yeast, so I want it in humans. So ERK1. And here we go, Homo sapiens. This is the one I want. And then go to sequence again, download, copy, go back to the Word doc, paste, keep text only, get rid of all the spaces. Okay. So now you have your proteins that you want to predict into a complex, the sequences of them. So now what you do is you take this, copy it, and so now you go to Colabfold, and the first thing you want to do is say connect. So this connects you to one of Google's servers to use one of their computers to run the simulation on. And then, so this is where you're going to paste your sequence in, but if you copy it from a Word doc and then you try to paste it in here, like I'm trying to paste it, and it's not pasting, right? And that's because in a Word doc, that's rich text formatting, and here it's asking for a single line formatting. So you have to convert the rich text formatting to single line formatting, and you can do that by simply just opening up another browser, pasting your sequence, and then copying, selecting all, selecting your sequence again, copying that, then going back to AlphaFold. Oh geez. Go back. There we go. Then go back to AlphaFold and paste in. The next thing you want to do is you change the job name to the two proteins that you are predicting are being a complex. So ORF45, ERK1. And that's all. That's literally all you have to do to give it to, that's all you have to give AlphaFold. And then you simply go, like literally do not mess with any other settings. Do not mess with them. I don't even know what they do. I'm not that skilled of a coder. But go to runtime, run all, run anyway, and then it will run, and when it has displayed 3D structures, it will come up here. There will be a score called an IPTM score or a PTM score, and this is your score that tells you how certain it is. So anything from 0.8 to 1 is like absolutely excellent, like definitely is a complex in vivo, you know, like very good prediction. 0.6 to 0.8 is like most likely interacts in vivo and is modeling what it looks like in a cell, but is less certain. 0.4 to 0.6 is like probably like may or may not interact. If it does interact, it's very transient and unstable. And then anything under 0.4 is just like doesn't interact. So that's how you categorize like the certainty of the models. But once it displays the 3D structure, open up this file compartment and go to the file that you have set up, and there will be something called PDB files, PDB, and that's what you want to download, because those files are what you're going to open up in Chimera. And you can watch the next video to figure out how to analyze a protein complex in Chimera. Okay?